You might think big companies would use languages like Rust and Go to scale, and sure, plenty do, but there's a secret weapon that a lot of these companies are using to let them scale much bigger and much faster with teams that are much smaller and more focused. That language has been around for a lot longer than you might think too. It's a language I love a lot. Well, not it, but the things that you can build on top of it. That language is Erlang from the 80s. It was built for phone companies, but since then it's been used for a hell of a lot more, including my favorite language, Elixir. Yes, not TypeScript, Elixir. I love it so much, the things you can do with it are incredible, and we're going to read an awesome article all about how these companies are using this stuff. So let's get to it. How WhatsApp, Discord, and other companies all have managed to scale to hundreds of millions of concurrent users, taking advantage of Erlang and the technologies that it is enabling. Huge shout out to Hoon Wee for writing this. I'm very excited for this article. As a solo full stack dev, one of the most popular projects our clients ask us to build is a real-time app. Oh, you know, the ones that you use every day. Things like WhatsApp, Discord, Slack, Twitch chat, etc. When building real-time apps, you need to consider for various factors like scalability, fault tolerance, responsiveness, and distribution. And that's a tough job, especially if you're a small team or even a solo team. One of my favorite fun facts is that when WhatsApp was acquired, they had, I think, 6 engineers total, maybe a bit more, but they had less than 6 working on the infrastructure. And man, the WhatsApp team killed it, and they were able to scale to unbelievable numbers of users with such a small team because Erlang made it easy. What if I told you that you could build a real-time app that can easily scale to more than 1 million users with just a few devs? And not only that, but you could also deploy them with almost zero downtime at extremely low costs. The secret weapon I'm talking about here is the Erlang virtual machine, or Beam, the Bogdan or Bjorn's Erlang abstract machine. Remember, Erlang is ancient. Erlang comes from like the OGC days. So they didn't have a real term of virtual machine yet. Like that concept was still new, largely being invented by Erlang. So the term was abstract machine because their goal was to make a layer that they could write code for, and then they could just port that layer over, kind of similar to things like JVM from Java. This was meant to be an alternative to how C worked, where the C language had to be ported to every different architecture so that you would write code and it would compile to the correct assembly. Beam was what we're focused on being a slightly higher up level, so you don't have to compile different code or compile your code for different platforms. You compile the runtime and you can stuff the code in, again, similar to Java. But at the time, that was revolutionary and also very slow because computers sucked, which meant that Erlang did not get adopted that much. But since then, the power of having that abstraction and the networking benefits and all the crazy stuff that got built into Erlang have proven to be very, very useful. At the time, or for the telephone companies, but since, for the internet we now know and love. Because believe it or not, Erlang was invented before the internet. So yeah, this will be a fun one. In this article, I'll explain how Erlang and its modern counterpart, Elixir, have become the secret weapons behind real-time apps like WhatsApp and Discord. I'm especially excited to share this because I've been using Elixir for more than 3 years now, and I can say it's one of the best decisions I've ever made in my career. Yep, there are very, very few people who can say they regret learning Elixir. I'm not going to promise you a bunch of jobs and opportunities as a result, but it will make you appreciate functional programming and scaling and networking and all these things in a different light, and it was certainly a very powerful thing for me to learn when I learned it. So let's dive in. The origins of Erlang and Elixir. That's such a good meme. That's so true. I was about to give the history, but I'm going to let the author do it and just add my details. Before we go into the history of Elixir, because we're going to have a lot of fun there, I have to plug ElixirConf. It's happening August 27th to 30th in Orlando, so if that time's already passed, I'm sorry. But if you want to come to a cool place to talk about Elixir and hear keynotes from Jose Valim, Chris McCord, the guys who made Elixir and Phoenix respectively, as well as this guy, who I don't know how he snuck in, but he did, come check it out. I'll even leave a discount code in the description, so use that if you want to get some money off. Anyways, Erlang was developed in the late 1980s by Ericsson, a Swedish telecommunications company. The goal was to create a language that could handle massive concurrency and high availability requirements of telecommunication systems. Again, they wanted to make this work for phone companies. The internet was not even a thing. They just wanted phone companies and their stuff to work properly. Erlang's design focuses on lightweight processes, message passing, and fault tolerance, making it ideal for building systems that require continuous operation as well as high reliability. Erlang's lightweight process allows for thousands or even millions of concurrent activities within the same system without significant performance degradation. This is kind of the magic of Erlang. The idea of like what we now know in JavaScript with the event loop, where you can have something going on and process other stuff at the same time, that you can have a function that is running that isn't reserving a meaningful amount of CPU or RAM at any given time. It's just IO that's being waited on. The idea of having more processes running than you have processors and threads in your processor. That concept was unbelievably powerful and still is to this day, especially when you consider at the time, there was no such thing as multi-threaded processors and multiple cores. Like your distribution method was multiple computers. And the only thing that knew how to even start doing that was Erlang. But it could also spin up multiple processes, in quotes, on the same machine and just wait for the first one to finish before doing the next one. All of these concepts were largely invented by Erlang because this idea of a process not being the thing directly tied to the machine itself, but being an abstract thing that you could run, pause, resume, queue, deal with later, deal with sooner. All of these ideas came from Erlang, which is so crazy. There's a great quote here we'll get to in a second. Its message passing model enables these processes to communicate efficiently without sharing memory, which reduces complexity and increases fault tolerance. The let it crash philosophy, this is like core to Erlang. Let it crash. It's fine because you can recover from the crash. Don't go out of your way to make sure edge cases are handled in every single detail because you can just catch at higher level and try again. The let it crash philosophy encourages devs to write systems that can recover gracefully from failures, contributing to the robustness of the Erlang-based applications. Elixir, created by José Valim in 2011, builds on the solid foundation of the Erlang VM, but it introduced some more modern and developer-friendly syntax. So I'll dive in a little more on here. Check out my interview with José if you want to see a bunch more, because it was awesome. I love him so much. He was one of the most relevant devs in the Ruby world. He built the OAuth implementation for Ruby, which was a huge deal. He realized that Ruby's scalability was shit, like absolute garbage. It's as single-threaded as a thing can be. So Ruby on Rails sucked to scale. We invented all sorts of new technologies to abstract on top of Rails, like outside of the server, to tell you which server to go to, because it was the only way to load balance. Hell, the concept of load balancing as we know it today was largely invented to deal with Ruby's bullshit. As such, José was annoyed and wanted to find something better. He soul-searched, he looked at every language, and he fell in love with what Erlang could do. But then he had to read Erlang code. And I should probably have started with this, but it's important to understand how fucking cursed Erlang syntax is. This doesn't look too bad. But like accessing sub values is largely done with like the number sign. There's a lot of code that has a semicolon at the start instead of the end. This is very modern Erlang. Okay, a good bit of this is relatively modern, but the dash for modules, also the concept of modules being something they had was insane. This looks not as bad as it usually does when I look at old Erlang code. Maybe my brain's being rotted by FP. It used to be fucking weird. Okay, now we're talking with the brackets, the underscore ats, like, what the fuck is this? Now we're talking. Yeah, it's one of the earliest languages of pattern matching. It might have invented pattern matching. What language was first to have pattern matching? ML in the 70s had it. Damn, did not know that. Good to know. But yeah, Erlang was one of the first languages with it. Not the first, but one of the first. Anyways, the point I was trying to make is that José saw Erlang, realized it was miserable to write and read, and wanted syntax that didn't suck. And let's be real, Ruby syntax is beautiful. It's like if Python didn't hate you. The promise that Python made of readable code like English was actually delivered on by Ruby, which is funny because the guy who wrote Ruby is not a native English speaker. The point being, Ruby had great syntax. José missed it when he started playing with Erlang and decided he would build a language on top of Erlang so we could have the beautiful syntax of Ruby while also having the performance benefits and ecosystem of Erlang. And he pulled it off with Elixir for sure, especially once he started adding all the fun functional programming things on top. It was great. Together, Erlang and Elixir provide a powerful stack for building scalable, reliable, and maintainable apps. Their features make them a perfect choice for companies like WhatsApp and Discord, which require systems capable of handling a large number of concurrent users with minimal downtime. We need to actually talk about those features though, because right now I'm just glazing the language. So let's dive in a bit. The 5 core features that make Beam a secret weapon for real-time apps. There's a reason these companies are using it. Excited to dive into it. First big feature is fault tolerance. See this? We got a supervisor keeping track of the workers. If a worker dies, supervisor sees it, and they spin up a new one. Love it. Also love the Excalibur. Reliability is crucial for applications like WhatsApp and Discord, which must operate continuously without significant downtime. Erlang's let it crash philosophy ensures that individual process failures do not bring down the entire system. Instead, processes are isolated, and supervisors can restart a failed process automatically. This design minimizes the impact of crashes and contributes to the overall stability of the application. The fact that everything in Erlang is its own like isolated worker always is fucking magic. It's so powerful. And you can do crazy shit like hot swap the code out live. Like you can just change what code is running because again, Erlang's like a virtual machine and layer. So you can just throw different Erlang code in and it will interpolate it and use it for whatever you want to. That's nuts. It's so cool. It's like one of those things that you don't realize because it could work in Java, but nobody uses Java that way. I don't even know if it can actually do that. The thought of things like hot swapping code, restarting individual processes and workers without hurting the system, crashing without the system going down, all magic and hugely useful at scale, especially if you're moving fast. Scalability. Scalability not only needs the ability to expand physical servers horizontally, but also methods to communicate between those servers. This is one of those things that Erlang just does. And once you see how Erlang does it, you get mad that everything else sucks so hard. We'll see what the article has to say first. But communication in distributed systems always brings several issues, from race conditions to node discoveries, orchestration failures, etc. There are lots of reasons why these issues are brought up, but most of them come from the ill-managed complexity. Beam, on the other hand, achieves scalability without any fancy yet dangerous tools out there. It handles internode communication like a charm. Let's see a simple example of how to communicate between two nodes in Elixir. So you have to spin up two nodes. So here's two different nodes spinning up here. This one is named node 1. At here is just where it's located, has a cookie. And we spin up another one here named node 2. So all I have to do to connect them, it's inside one of them, say connect to the other one. Node.connect, node 2 with the IP. And here is where shit gets actually fucking magical. Do you know how you run different code on that node? From this node, call node.spawn and just pass it a function. It will just run over there. What the fuck? Why does no other language have this work this easily? These aren't necessarily different processes on the same machine. These could be different machines entirely. And you can just spawn a process on a different machine from the one you're currently on. It's insane. It's so powerful. And when you get into shit like Gen Server, show me an Elixir Gen Server example that distributes the compute to process an array across multiple nodes. Gen Server is nuts. It's a generic server that makes it easy to distribute shit. Cool. Showing all that. Cool. As you see here, it looks a lot like Ruby. Sad that there's no Elixir syntax highlighting on ChatGPT, but I get it. And all you have to do to distribute these, we have our nodes, which we just get from calling node.list. We now know how many nodes there are by calling length of nodes. We break up the array. We then chunk every for this amount. So there's now chunks of however many, like let's say there's 5 nodes. We now have chunks of 5. So for each chunk, we then spin off an async process for each of those. It's that simple. It's like real easy, like hilariously so. And we just have the Gen server that creates the link and actually spins up all of these processes. And we can just chunk on an array, which by the way, the ability to chunk on something like this is magical. To just split up your data in groups of 5 with a helper like that. Oh, so good. For those wondering how does this work, it assumes the same source code is available and tagged properly on all nodes, which it pretty much always is. And it's updating itself, as far as I understand, to make sure all the nodes are on the most up-to-date source. It's not actually sending the source code across the wire. It's sending a tag to what source code to run across the wire. From my understanding, I could be wrong. But these are the things you don't think about when you use Elixir, because they're all just kind of solved for you. You have the node 1, node 2 here example, node.connect to node 2. We can distributed compute.start link. Now we have the 2 nodes. Result, distributed compute.process array, the array. Can you give an example without a module where you do it all as one big function with pipes? The pipe operator is one of the coolest things in Elixir, by the way. Yep, this is how I would have written this. Now we're talking. So we have the node list, and we can cat self to it. So now we have all the nodes, including this one. Chunk size, again, we're dividing the length of the array by length of nodes. Create the chunks, enum.zip nodes.map. So the zip is attaching the node in between each element. So now we know if we grab 2, it's the chunk, then the node. Task.async, we pass this thing through the RPC call, the distribute example, process chunk, end, and that's it. And if you want to see how the chunk's processed, that's this code here, the module. Def process chunk, does whatever you do here. And all you have to do to call that somewhere else, because again, we're calling this function on a node we don't know. The node is this node. So we just call that by passing this node, and then calling process chunk, and also distributed pipe, because we need to tell it which module, because we're in this distributed pipe example module. And we're telling it, in this node, call this module, specifically this function, and pass it this data. It's actually really nice, like magically so. I'll just sit here glaze Elixir all day if I keep looking at code snippets. So back here, As I said, this is really powerful and scalable, and you can avoid using complex distributed systems like Apache Kafka, RabbitMQ, and things like that. The amount of time I spent avoiding these things because Elixir and Erlang just did them for me probably hurt my career as much as it helped. Getting some good questions from chat already, like, does this relate to the wild shit Fly does? Yes, this is how Fly works. Fly functions entirely because they're building everything on top of Elixir. People saying that my hair is convincing them to check out Elixir. Oh boy, I'll take it. The hair seems less sincere. The hair's convinced you. I'll take it. Anyways, distribution. This is where it gets even more fun because, again, you can run this on any node and it's very trivial to spin up. Real-time global applications like WhatsApp and Discord require distributed architecture to handle users from different regions. This needs a system that can distribute workloads across multiple nodes and ensure seamless communication between them. Beam Scheduler can not only distribute processes across multiple cores on a single machine, but also across multiple machines in a network. So fucking cool. And also, it treats every process the same, whether it's on the same machine or a different one. This is kind of the magic. You can wait for a result of a process and call it as though it ran on the same machine, even if it ran on the other side of the fucking world. It doesn't care. And obviously, this makes it very easy to build distributed systems without worrying about the underlying infra. Computer 1, Computer 2, Computer 3, all getting things passed to them from the scheduler, it doesn't fucking matter. This ease of distribution also connects to the scalability feature. When you need to scale your app, you can easily add more nodes to the cluster and distribute the workload across them. No need to worry about complex load balancers or sharding strats. Beam takes care of it all for you. Yep. You could hire a team of DevOps to do all these things for you, or you could just use a good language. It's also worth noting, I'm going to drop a spicy take when we're here. Performance means a lot of different things. I find a lot of companies getting excited about languages like Rust because they want to squeeze out all the performance they can. But man, performance is not that simple. Performance means that your app runs well, or that the thing you're building runs as expected. It doesn't mean that the amount of time it takes to do a specific math function is as short as possible. It means the whole system runs well. So as much as Rust might make a given function compute faster than other languages, certainly faster than Elixir, because Elixir is not a compiled language, it won't benefit once you want to go past what your current processor does. One of the most important things to know about performance is that performance is often a function of scale. How many processors and threads do you have? How well are they being utilized? I've seen a lot of code in Go and in Rust where the Go code is faster, not because it can compute a function or get data faster, but because it's easier to parallelize the things you're doing in Go than it is in a language like Rust. I know I've gotten flamed for the Rust sucks at async takes, but I don't care. I'm right. Rust sucks at async. It doesn't do concurrency well for shit. It certainly doesn't do parallelism well for shit. You can brute force it in, but good luck, have fun. Erlang just does it. It's just part of the language. And that's the magic is, while yes, if we're comparing how much compute can get done on one core, Elixir loses. It solves a much more complex performance problem that matters a lot more to businesses that are actually making money, which is when we hit the cap of how much performance we can get out of one box, how easily can we have a second box? And sure, if you could theoretically only ever have one server, Rust is a great language for that. But as soon as you might need a second server at some point, Elixir is the best thing you can be using. And if you want to be able to spin up multiple nodes and distribute your processes so that you can get responses to users faster without micro-optimizing every single fucking line of code in your app, that's the performance win that you get from Elixir and Erlang. They make it easier to scale up to address performance needs rather than Rust, which makes it easier to write individual lines of code and functions that resolve way faster. As great as that is, and it is awesome, it is not going to solve the problem as indefinitely as something like Elixir and Erlang does, because these mean whenever you need more performance, just spin up another server. No other language has this good, period, unless it's also built on top of Beam. So, speaking of performance and how quick things handle stuff, let's talk about responsiveness. Real-time communication platforms must deliver messages and updates to users quickly and reliably. I mean, don't tell that to Slack or GitHub. Anyways, Erlang takes the execution of multiple processes into its own hands by employing dedicated schedulers that interchangeably execute many Erlang processes. A scheduler is preemptive. It gives a small execution window to each process and then pauses it and runs another process. This is so magical, you have no idea. So here's an example. The scheduler allocates an execution window to process 1, which allows max 500 function calls per process. So if this needs 1,000 function calls, but it can only take up to 500 at once, then after it's hit that 500, it pauses and goes to the next process. Since process 1 needed 1,000, it's paused. It then tries process 2, which only needs 100. So it finishes that, and then it can go back and finish that. This sound familiar? If you're deep enough in JS, you're familiar with the event loop. This is like a brute force, scalable, multi-node version of the same thing. It's so cool. Just got the question, how does Gleam compare? It's the same because both Elixir and Gleam are built on top of Erlang and Beam the same way. I'll say Gleam's whole like compiles to JS thing won't get any of these benefits, but if you're using it on the server side with Erlang, it's the same thing. It all compiles the same thing. The same way that like Kotlin isn't faster than Java, all the languages built on top of Java are the same. Because the execution window is small, a single long-running process can't block the rest of the system. Furthermore, I/O operations are internally delegated to separate threads, or a kernel pull service on the underlying OS is used if available. That means that any process that waits for an I/O operation to finish won't block the execution of other processes. Again, it's doing a lot of the same things that we love JavaScript for and the things that actually make JavaScript surprisingly fast, but it's doing it across machines. That's nuts. That's so cool. Speaking of cool, live code updates. Nothing else has this. Maintaining real-time applications requires the ability to deploy updates without disrupting the user experience. Usually, in a containerized cloud environment, you would use techniques like blue-green deployments, canary deployments, etc. to achieve this. But with Beam, you can update code on a running system without restarting the application. Do you understand how magical this is? Imagine something like a WebSocket server that you're connected to get new chat messages. Now imagine you're the dev of that server. You need to push an update to change how the processes are being shared or what database they're connecting to or something like that. Normally you'd have to take down the server and put up a new server and then hope the user automatically reconnects and write a ton of client-side code to make sure they can reconnect to the right thing. Now you can just put up the new code and you're done. It's nuts. This feature is known as hot code swapping, and it's crucial for real-time applications where continuous operation is essential. It allows for devs to fix bugs, add features, and optimize performance without interrupting the service. Oh boy, we're getting into case studies now. This will be very fun to see how these things are actually being used. I love the ABC here of context on what this is, examples of why it's powerful, now examples of how it's actually been used. How WhatsApp leveraged Erlang to scale real-time messaging with more than 1 billion daily active users. That's so hard to comprehend. In 2009, WhatsApp was founded by Brian Acton and John Combe, who wanted to create a messaging app that was cross-platform, fast, reliable, and secure. They chose Erlang as the foundation for their real-time messaging platform because of its fault tolerance, scalability, and distribution capabilities. The basic architecture and codebase for WhatsApp's messaging systems were inspired by an open-source project named eJabbered. It was an XMP server written using Erlang. WhatsApp growth was exponential, and by 2018, it had over 1 billion daily active users. Thanks to the efficiency of Erlang and their careful refinement of both eJabbered, they managed to handle millions of messages per day with minimal downtime while keeping the team lean and the hardware and engineering costs low. Yeah, I want to emphasize like how many engineers worked at WhatsApp when acquired. They had 32 engineers. If I recall, 6 of them or so were on infra, and that was for a $19 billion acquisition, and that was 6-ish people covering 450 million active users. That's so hard to fucking fathom. That's so crazy. That ratio is unbelievable. It's possibly the craziest of like number of devs to number of active users connected. Whew, unbelievable. According to Anton Lavrik, a WhatsApp server engineer, one of Erlang's best attributes is the concurrency. He says that other languages or platforms can try to achieve the same level of concurrency, but they often require a lot of effort and resources. Since Erlang was built to solve the problem of concurrency from the beginning, it's much easier to achieve the same level of concurrency with Erlang. Yep. And case 2 is Discord, which is a relatively well-covered story. Even on the Elixir blog back from 2020, Jose wrote an article about why Discord was on Elixir. So that's a really cool thing if you want to check that out. Great reference. Let's see what the author of this has to say. Discord, founded in 2015 by Jason and Stan, is a real-time chat app designed originally for gamers. Also devs, by the way, t3.gg/discord if you want to hang out with us. Back then, they chose 2 main languages to build their infra, Python and Elixir. This is particularly funny because since then they've done Go and Rust and a bunch of other shit. The Python codebase in Elixir still remains for powering API-related stuff, but most of the core features, including real-time chat, are still powered by Elixir. So the Python, I don't think the Python codebase is being used for fucking anything, but the real-time chat absolutely is Elixir powered. Discord's popular servers, such as those dedicated to popular games like Fortnite and Minecraft, can handle hundreds of thousands of users chatting simultaneously. Hence, it should be very good at broadcasting messages and user status updates in real time without any delay. Elixir's concurrency model and fault tolerance features made it an ideal choice for building Discord's real-time chat system. The ability to handle massive concurrency and distribute workloads across multiple nodes allowed Discord to scale its chat platform while maintaining high performance as well as reliability. And then in 2019, Discord reached a new milestone. They had to handle way more concurrent users than ever before. This time they had to use not only the powers of Beam, but also the powers from other more so-called performant languages. They used Rust to build their new member list that could rapidly update the status of 11 million plus concurrent users. And the cool thing is that they adopted precompiled Rust modules into the Elixir codebase, using a feature called NIF, which is native implemented functions. Really cool that for the things that, again, Elixir doesn't do fast, because it's not a fast language, it's a scalable language. You can still dive into something like Rust to do certain things fast, and then send out the response across the crazy node management stuff that you can do in Erlang. This way, they could leverage the performance of Rust while also using the productivity and scalability, concurrency, and all of that of Elixir. Super cool. Case 3. This is the case that the author worked on. How I built a real-time networking app with Elixir and Phoenix. Last year, I had a chance to build a fun project called Food Focus, which broadcasts a live video of a user cooking a dish, and other users can join the live video and chat with the host. Not only that, but they can also connect their smartwatch to the application, and the application will show the synchronized recipe instructions as a timer on their watch. By the time I started building the project, I had to choose the most cost-effective tech stack to build it. The most important traits of the tech were the following. It needed to be easy to build real-time features. It should provide ready-to-use tools so they don't have to bring in a lot of third-party stuff. It should be fun to work with. A nice DX. Oh, we were doing so good. So good. Threw it all away at the end. This hurts me. After some research, I decided to use Elixir and Phoenix for the backend and make a mistake on the front end. I'm sorry. I love you, author. You've done a great job with this. The fact that you were willing to try out new things and find Elixir and Phoenix is also why you were willing to try Flutter, but I hope you take the time to reflect on why Flutter sucks. Ugh. Especially if you need a mobile, like a watch app, Flutter is going to only get in your way there. Ugh. I don't want to rant about that because I fucking love this article. So, though it was my first time building a production-ready app with Elixir, I was amazed by how easy it was to build real-time features with Phoenix. These are some of my favorite features and tools that I found very useful while developing the project with Elixir. Phoenix channels, which are a great way to build real-time features. They are built on top of WebSockets, and they provide a simple and easy-to-use API for building real-time apps. ETS, which is the Erlang term storage. It's a built-in key value store in Erlang that's very fast and efficient. No need to bring something like Redis for caching or storing temporary data. Also, Postgres-backed tools like Ecto for the database operations, Oban for background jobs, and Electric SQL for running local-first queries with better UX. Good stuff. Thanks to these features, I was able to deliver the project on time and within budget. If I had chosen a different stack, I might have spent more time configuring and integrating third-party libraries and have less time to focus on building the actual features. Yeah, conclusion. WhatsApp and Discord are exemplary cases for how the Erlang VM and Elixir can be leveraged to build scalable, real-time apps. However, they are not the only companies harnessing the power of these technologies. Other prominent companies like Spotify, Pinterest, PepsiCo, Financial Times, Heroku, they miss Fly.io, but they're a great example too. These companies have all adopted Erlang-based languages to achieve high concurrency, fault tolerance, and scalability in their respective domains. Also Twitch. Twitch isn't using it anymore, but we used it a bunch for the marathons, and it was so good for that. It was so good. In conclusion, whether you are building a new messaging platform, a real-time gaming service, or any other hyper-connected app, I strongly encourage you to consider the Erlang VM and Elixir as your secret weapons for success. Their unique features and capabilities can help you establish a strong foundation for your app and scale it to new heights without compromising on performance or reliability. Thank you, Hoon, for writing awesome article. I loved every word of this, other than the word Flutter. I am so thankful you wrote this and that you gave me the opportunity to once again rant all about how powerful Erlang and this whole ecosystem is. Let me know what you guys think in the comments, because I know Erlang and Elixir aren't for everybody, but I think it might be for you. So let me know. And until next time, peace, nerds.